So, good morning. My name is Sekhar Reddy, Senior Physics Faculty. So, today we are going to discuss about electric field at any point due to an electric dipole. Due to an electric dipole. So, already in previous seasons or videos, I was explained about what is electric dipole, intensity of electric field on axial line, and the intensity of electric field on equatorial line. So, like this is special property or special case, electric field at any point due to an electric dipole. So basically we know that electric dipole means two point unlike charges separated by a certain distance is called electric dipole. Dipole length represented to L, the length minus charge to plus charge. The line joining negative charge to positive charge is known as dipole axis. So dipole moment is the vector quantity that direction always negative charge to positive charge along dipole axis. So these are totally, we know that in previous topics. Now here electric field at any point due to an electric dipole. So now consider electric dipole. So like this is known as electric dipole. The charge minus Q and plus Q. Minus charge at point A plus charge at point B. So that dipole length we know that here. Now consider one point at the exact center that is known as center of the dipole. Our aim is to find out at any point. Now consider one point at this point. Like this is point P. So this point P, now consider one of the point that is at any point. The point P at a distance or from the center of the dipole, like this is center of the dipole, makes an angle theta with the dipole axis. So we know the dipole moment direction negative charge into positive charge. Like this is dipole moment direction. Like this is dipole moment. So here P is the one point. Like this P is known as dipole moment. This P is known as dipole moment. So once again, consider a dipole length AB of length to L. Dipole length AB. The AB length is taken as 2L. Minus charge at point A plus charge at point B. Let point P at a distance or from the center of the dipole. Center of the dipole makes an angle theta. Dipole axis like this. Negative charge to positive charge is on dipole axis. So a dipole P can be resolved into two components. Dipole P can be resolved into two components. One component P cos theta. Along dipole, along OP direction. Next another dipole. The dipole moment can be resolved into two components. One component P cos theta. And this is P sin theta. So your dipole P can be resolved into two components, P cos theta along OP direction and P sin theta perpendicular to OP. Perpendicular to OP. So like this is known as dipole. Original dipole moment. P cos theta and P sin theta. Here angle is 90 degrees. So this is dipole P cos theta. The angle between these two dipole moments 90 degrees. So next to the dipole length AB, the dipole AB consider as two dipoles. One dipole A1, like A1 and B1. One dipole A1 B1 of dipole moment P cos theta. Another dipole A2 B2. Another dipole A2 B2 of dipole moment P sin theta. Dipole moment P sin theta. Here dipole moment P cos theta along the OP. Dipole moment P cos theta along the OP and dipole moment P sin theta perpendicular to OP. Perpendicular to OP. Now electric field due to dipole moment P cos theta, let be E1. E1 along OP direction. OP direction like that. This is point P. Point K. So what is the reason? Like here, point P on axial line of dipole moment P cos theta. P cos theta will from negative charge to positive charge. Yeah, A1. So next two, let E2 be the dipole moment by the B sin theta. P sin theta. P sin theta perpendicular to P sin theta. So here P point P or P sin theta perpendicular to point P or P perpendicular to second dipole A to B. A to B. The direction line perpendicular here. Like this is E2 along Pn. That result all four. So now consider once again. We will write the point. Consider a dipole of length AB having charges minus Q at point A and plus Q at point B. So once again, consider a dipole of length AB having charges minus Q at point A, so plus Q at point B. So the direction of dipole moment minus Q to plus Q along the dipole axis. Now second point, let P be the point. Let P be the point at a distance of distance or from center of dipole makes an angle theta. Angle theta with dipole axis. Dipole axis. Like this is point P considered. So what is the distance from center of the dipole to up to here or makes an angle theta with the dipole axis. Next point, like this dipole along this direction, this can be resolved upon P cos theta and P sin theta. Now dipole moment P resolved into two components. One component P cos theta. One component P cos theta along OP and other component P sin theta perpendicular to OP. P cos sin theta perpendicular to like OP here, perpendicular. P cos theta component OP direction, P sin theta component perpendicular to OP. Next point, dipole AB of dipole moment considered as two dipoles. One dipole A1 B1 of dipole moment P cos theta and other A2 B2 of dipole moment P sin theta. Dipole moment P sin theta. P sin theta. Let E1 and E2 be the electric field at point P due to P cos theta along what direction? PK, along PK. And P sin theta along here. So here PK parallel to dipole axis, P cos theta, that is the point P on the axial line of P cos theta. Next P on equatorial line of the P sin theta. Therefore, E1 bar is equal K. On axial line, we know that 2P cos theta, that means 2P cos theta by R cube. Second one E2 on equatorial line. Actually, KP by R cube. Here, P instead of P sin theta. KP sin theta by R cube. KP sin theta by R cube. The resultant electric field resultant electric field at point P is given by E bar. So therefore E bar is equal E1 bar plus E2 bar, or mod E bar is equal under root of E1 square plus E2 square plus 2 E1 E2 cos theta. But here theta is equal to negative, that cancel. Now E is equal. When what is the E1 value? K 2P cos theta by R cube and square, that means whole square. R cube whole square plus E2 KP sin theta by R cube whole square. Now K into K square P square, here 2 4 cos square theta by R cube whole square. R cube whole square means R power 6. So here K square P square sin square theta by R power 6. So here what is the common? K square P square and K square P square, R power 6, R power 6. These are common. K square P square by R power 6 in bracket remaining 4 cos square theta plus sin square theta. Inside root K square, the root outside will take in K only. Inside root P square, outside P, R power 6, outside R power 3. So we have to write 4 cos square theta. So sin square theta value, we have to write 1 minus cos square theta. 1 minus cos square theta. So therefore E is equal, K value substituting 1 upon 4 pi epsilon naught P by R cube 3 cos square theta plus 1. So this formula will use to find the intensity of electric field at any point due to the dipole. What is the formula? So E varies at point P. E is equal to under root E is equal to 1 by 4, 1 upon 4 by epsilon naught P by R cube under root of 3 cos square theta plus 1. 3 cos square theta plus 1. Suppose note you should remember, if theta is equal to 0 degree, theta is equal to 0 degree means the point P moves down and coincides here. That means axial. Theta 0 degrees. Theta 0 degrees means cos 0 value 1. That means, so 3 plus 1, 4. So therefore we'll get that is my answer. E is equal to 1 upon 4 pi epsilon naught 2 pi by r cube. If theta is equal to 90 degrees, theta 90 degrees means that point P moves this side, that is exactly perpendicular bisector of the original dipole moment. Cos 90 value how much? So 0. That means this term becomes to 0. E equatorial is equal 1 by 1 upon 4 pi epsilon naught P by R cube. P by R cube. So now direction. Direction of electric field at point P is so direction represented in terms of tan. Here tan theta is equal to alpha. Tan alpha is equal to this is opposite side. Opposite side. These two are will consider parallel. So that means PN and adjacent. Tan alpha is equal to opposite side by adjacent. Opposite PN by adjacent side means PK. That is equal. Opposite field how much? E2 by adjacent field how much? E1. So E2 value, we know that E2 value how much? E2 value this one. Kp sin theta by R cube. Next E1 value K 2p cos theta by R cube. So K get cancelled, PP get cancelled, R cube get cancelled. That is equal to how much? Therefore, tan alpha is equal 1 upon 2 sin theta by cos theta. That is equal to 1 upon tan theta. So therefore, alpha is equal tan inverse of 1 upon 2 tan theta. This is the direction of the electric field at point P. This is the direction of electric field at point P. So like this.